All right, how do we run an independent samples t-test? It's really easy. Remember, we have different tabs. I've never used the edit tab either. I only use analysis and data. Analyses, I click on t-test, independent samples t-test. Analyses, t-test, independent samples t-test. Analyses, t-test, independent samples t-test. Now, dependent variable is my outcome. My predictor is my grouping variable. I click here and here. Now, one of the things I want, when your effect size, this right here is negative, I want you to do an extra step to make this positive. The negative sign on the effect size for your sample doesn't matter. So I want to make sure my sample effect size is positive. That means my effect size positive means the direction I found in my data set. So I am going to go ahead and click on my data. I'm going to double click my predictor. And I'm just going to click this button right here and click it up. And you'll see that the negative signs on the effect size changed. This will just help you manage things. Now, I taught you how to make plots by hand. These plots that I'm going to currently click are not usable in your write-ups or anything like that. I'd rather you make ones by hand for now and learn a better graphing tool when we get there. You can see it doesn't have the things I like and it doesn't have bars. It's what it is. But it allows me to see that group B has a higher mean than group A, right? So that's what the effect size is referring to. Positive means group B is higher than group A. That's all it means. Let's go through the output here. You're like, here's a t statistic. You don't need to know what that means. Degrees of freedom. You don't need to know what that means. You need to know where it is. This is the thing you know. P times 5.6696 times 10 to the fourth. One of the things I want to show you is we can go ahead and, alter our options up there. I'm going to show you that again. If I just click this little button right there, I can click my display options. You can have different number formats for numbers, 4 sig figs, 5 sig figs, 3 sig figs. That's ultimately, I actually do prefer 3 sig figs, but my p-value I want out for as long as I can get it out. There's other options there you can play around with. But ultimately, this P is less than 0.05. This is significant. I've crossed the threshold for trustworthy science. If you don't get a significant p-value, your science is not trustworthy. That is how I'm going to teach it. It's way more complicated than that. But for us, learning to drive the car, that's how you drive the car. So Cohen's D effect size here, 3.15. Cohen's D's effect size is 0.2 or small. 0.5 is medium. 0.8 is large. This is a large effect size in the sample. So in my experiment, this difference where B is greater than A is a large effect. So we have a significant large effect. The 95% confidence interval here is your 95% confidence interval of effect size. This tells you your population effect size. I like to, when we report it, we will report these numbers. Don't worry about that. I like to understand this. I like to convert this into its effect size label. This is a large effect size in the same direction that we found in our data. This is a large effect size in the same direction we found in our data. This positive here, that's the direction of our data. This is positive and this is also positive. All right. Our population effect size, if this data were real, I made it up, is between large in the same direction I found and large in the same direction I found. Most of the time, both of your labels do not end up the same. You will have something like small to large, less than small to large, and those are things we will talk about in class about how to interpret. This is how you get your data.